So in this Lathe 100 series, we're going to look at some basic tooling that may or may not come with your lathe, or that you may or may not need in your shop. What the differences are between all these different terms, whether they be high-speed steel or brazed or insert or titanium or cobalt and oxides and all these other terms that you may be kind of buried with and may not be familiar with. Also, what is the difference between quality and prices on various tools? Why should you spend more or less? What's it going to buy you? What is it not going to buy you? Things along those lines. This is not anywhere near complete. This is a very basic set that I've got here in front of us to give some examples. If you enjoy this video on this topic, please give it a thumbs up and leave in the comments, and I can go into further detail on these if need be and if desired. But this is just an initial rudimentary introduction. I'm going to give a quick overview first of what we're looking at here. All of these square shanked tools along the back and along this side are all lathe cutting tools. Here in the middle we have various drills of different types and materials. We're going to start with looking at these lathe tools, and then we'll step on through the different materials, the different shapes, sizes, so on and so forth. Then we'll continue on and look at the drill bits next. So here we're going to look at some of the different materials in several right-hand cutters we have here. These are all in theory the same geometry and would be used in the same method when turning on the lathe or doing facing operations, other operations. First one we're going to look at here is a high-speed steel bit. The high-speed steel bit is what comes standard on the Sherline and is definitely the oldest material of these shown here that's been used in the industry. One thing that you will probably need to do if you are going to use high-speed steel bits quite a bit is you will need to get a grinder and learn how to grind these. They do dull more rapidly. You can cut pretty much any material you want with these. It is just simply a matter of sharpening them more frequently. Now the sharpening aspects of them, the tips may look fairly complex to grind, but as long as you do it a few facets at a time, it's fairly straightforward and simple to do. There are quite a few videos out there already on how to do that grinding, so I'm not going to go into a lot of detail here on that, or what the different angles are and why you should adjust them. If you're mainly turning brass and aluminum, then this is going to last you quite a while, but if you are turning some harder materials or more abrasive materials, this is going to dull much faster, and you may want to look at some of these other options. These next two here are brazed carbide bits. The carbide gives you the advantage of lasting a lot longer. The carbide is a harder material, so it's going to hold up well and not need sharpening as often. The drawback to carbide material, such as on these two, is that it's going to be harder to sharpen. You can do it with a silicon carbide wheel or a diamond grit wheel, and just touch up the edge of these. Depending on the quality of the cutter, you may have to do that right from the factory. Some of these may not be sharp right off the bat, so be aware of that. With these cutters, you're going to see a variety of letters and numbers on the side of them. I'm just going to talk about these last two right now, rather than the shapes of the tools. This is indicating the hardness of the carbide, so whether it's a C2 or a C6 carbide, C2 being softer, C6 being harder. You might think, well, I want to always use the hardest carbide I can for the best wear. The drawback is with that hardness also comes additional brittleness, so you have to be more careful with the harder carbides. The C2 is better for roughing materials and doing interrupted cuts where you might be impacting the cutter a little bit more. So that's where that will come into. C6 is going to be used for your finish cuts and is going to hold its edge longer, and where you'll want to use that. And there's a range of these, and I would recommend looking in something along the lines of a Machinery's Handbook for all the details and recommended specifications of which type of carbide to use on which materials. Okay, this last tool that we have here is an Indexable carbide insert tool. These you'll primarily see with carbide as the insert, but they do make other materials now. Sherline, for example, makes a ceramic insert tool for turning some of those hardened materials. These were originally designed for use with manufacturing, but they've really come down in cost to where it's accessible for the home shop user, and is a good alternative because you're not going to have to worry about whether or not your tools are sharp. These cutters are indexable, so you can get 3 cutting surfaces out of them by removing the screw in the middle and simply rotating it. Another nice thing on this particular one is it has a chip breaker, so that should help with breaking up some of the long strings of chips that come off, so that you end up with shorter runs that are less dangerous, rather than 3 or 4 foot pieces of steel that might be peeling off of your workpiece. These inserts come in a variety of shapes and sizes. You can get inserts that are specifically for steel, inserts that are specifically for aluminum, inserts that are specifically for cast iron. So there are a lot of options to go there. There are a total of 10 digits and characters that will describe these inserts. If you want to see that, again, look at the machinery handbook. It will explain what each of those are. In this introductory video, I'm not going to cover all of those details. So now that we've looked at the materials, let's start looking at some of the different shapes that you can get in lathe cutters. These are all still, we're sticking with square shanked cutters right now. I'm just going to show you all brazed inserts here, brazed carbide tips, rather than mixing and matching. These shapes you can get in any of the tools, whether you're going high-speed steel or indexable or whatever else you want. We're going to start right here on the left side, and this is a right-hand cutting tool. The right-hand tool is designed to cut from right to left on a round piece, or it can be used for facing operations as well. We'll talk about the differences there. These two cutters are very similar. They just have different angles as far as clearances. Both of these can be used for interchangeably, pretty much for most tasks. Depending on specifically what you're doing, one may be a little bit better at chamfering, or maybe better at other items, depending on how you have it aligned to the workpiece. I added in 2 more shapes here that I had forgotten to lay out at the beginning. These are left-hand cutters, so these are basically the mirror opposites of these 2 guys. As you can see, looks like maybe there's some, with cheap tools, you'll definitely see some variances. If you look at this brazed cutter versus this brazed cutter, there's a definite difference in the angle there, and these are simple. These should be mirrors of each other, so these should be identical. This one looks like it's got some manufacturing flaws. This is what you get for buying lower end tools. Every once in a while you're going to find a tool that needs to basically be thrown out. In the case of this one, the brazed insert is just completely unusable. It's just set too far down on the tool. So be aware of that. You do get what you pay for. However, these tools are still much cheaper than buying a high-end brand name for the hobbyist, even if you do have to throw out an occasional tool. So next one we're going to look at is a 60-degree thread cutting or V-grooving or grooving tool. It's mainly used for cutting threads, but it can be used for any other grooving operations, including facing operations if you wish to. The nice thing about this tool is it can cut both left and right. There is no specific direction to it. This last tool is square-faced and is designed mainly for chamfering, but it can be used for doing a few other items as well. You can find all kinds of different shapes of tools. These are just some of the most common ones out there. Depending on what you're looking at, again, depending on high-speed steel versus brazed versus indexable inserts, you're going to get some different shapes. You can also get forming tools for cutting radiuses and coves and all kinds of different shapes. A lot of those you may have to grind yourself, depending on exactly what it is you want. So these two items are examples of boring bars. So these are designed to be insert into a hole that already exists, and to then enlarge that hole and to make the size more accurate. These are going to give you a much more accurate size hole than a drill bit, and typically after you've bored a hole to size, if you want further perfection, you'll use a reamer, whether it be a hand or machine reamer, to get it perfectly concentric and round. Difference here is size. This is a high-speed steel square 1/4 inch tool. This is a Indexable Carbide insert 3/8 inch tool, and it's designed to go into a round holder. The body of it is rounded. It has flats machined on it for indexing as well. These come in different sizes, which indicate how big of a hole you need to begin to start your enlarging with. This is obviously going to be able to fit into a smaller hole because the bar is considerably smaller compared to this. So that's something to look at. There's another variation of these which has the point facing more directly to the side and a 60-degree included angle for doing internal threading. So in a previous video we talked about tool height alignment to the center line of the lathe, which is definitely a key item. I also now want to talk about basically the overhang that you're going to put on your tool. This tool you can mount to where it's extended all the way out there, and you might think that that's a good idea because you can do deeper cuts and you're farther away from the workpiece, so you're going to be safer and not accidentally run into something. The problem is that this adds a lot of flexibility and weakness over this length. So really, to get a finer cut, you want to have this as far as you can practically and safely mount it back. This way it's got the most material supporting it underneath, and you've got the least amount extending out. One other item to consider here in the tool selection is the thickness of the tool. So this is a 1/4 inch tool. The sizes of the tools you'll often see on a lathe like the Sherline is 1/4 inch, 5/16, and 3/8. There are other sizes, both smaller and bigger. Typically you'll want to choose the largest tool that you can use for the application, again for that rigidity and the increased mass of the tool. Now there are going to be some times where you're micro machining or getting into very small spaces and you need to use a very small tool, even considerably smaller than the 1/4 inch shown here. So here we have 4 standard twist drill bits. You've probably seen these before, used these before. They're commonly used on wood, metal, ceramic, concrete, plastics, variety of materials with some small variations. You definitely do get what you pay for in regards to drill bits. This first bit that I've got shown here is simply a high-speed steel bit, but it's a good quality high-speed steel bit. This is going to work for all of your drilling needs in the home shop if it's a good quality bit. You can upgrade to some other options and add some other coatings or materials depending on what you're doing, but for the most part you're better off spending more money on a good set of high-speed steel bits rather than buying a cheap set of some of the more exotic sounding and fancier materials. One other thing that is important when it comes to drills is sharpening them, and sharpening them by hand is fairly difficult. There are some jigs and tools out there to help you out. I would recommend purchasing something along the lines of a drill doctor if you're going to be doing a lot of holes in metal. The next bit here is actually from a set. It's from a 115-piece set that includes not only fractional drill sizes such as the 1/8 and the 7/32 and things along those lines, down to 64ths on the fractional bits. Bits also will come in lettered and numbered sizes for different uses and to get more precise holes for drilling, say, taps or clearance holes, things like that. This set was a fairly cheap set in the neighborhood of you'll see them for around $40 to $100. A lot of times in those sets, these bits are already bent. They're very dull. They're just not very good quality. The advantage, though, with purchasing a set like that is you will have a bit of every size on hand. It may only work for a handful of holes before it breaks, or it may be too bent to use, or you may have to try to straighten it. You may have to sharpen them right out of the box, but it does give you those range of sizes, so in a pinch you'll have one. If you want to get a good quality set, you're looking at anywhere from $300 to $600 for a good quality high-speed steel set, and then on up from there with additional materials or higher end units. The material shown here you'll often see advertised as a titanium drill bit. This isn't titanium. It's a coating that's on here. You'll often see this also listed as TIN, which is a titanium nitride. This is simply a high-speed steel bit that has this titanium nitride coating applied to it. The purpose of the coating is to reduce friction and thereby reduce heat and supposedly make the tool last longer. This coating will wear off with time. In a non-production environment, you're really better off with lubrication rather than just relying on this type of a coating. It's not going to hurt. I mean, it will help having this coating, but definitely lubricate your drills, and that's going to be better than any coating that they can ship with. I'm going to skip over this third bit just quickly and jump to the back bit. Obviously this has a hex shank on it and is a little bit shorter, but the main thing I wanted to point out here is that this is a black oxide coating. It's another high-speed steel bit with another coating. This coating is supposed to reduce friction a small amount. It's not as good as the titanium nitride coating, but the big thing with this coating is it's designed to help prevent rust if you're in an environment where your bits are going to be getting wet. So when you see that, now you know what the black color is on most of those bits. This third bit that we skipped is actually made out of a different material. So this bit is made out of cobalt. Cobalt is designed again for production runs, for drilling into harder materials. So if you're going to be drilling into a lot of abrasive or harder materials such as stainless steels and things along those lines, you may want to look at purchasing some cobalt bits for that purpose. The cobalt bits do usually start at about double the cost of a high-speed steel bit, so you do pay more, but you may get more life out of the bit. You may get cleaner holes if you are running very hot, things along those lines. So here we have two center drills. I mentioned previously that when drilling in metal, we're probably going to be using a center or starter type drill to begin with, to make the hole a little bit more accurately located. These are both what are considered number 4 drills. You can get a variety of sizes of these. These are two larger units than what come in any of the kits with Sherline, but they're fairly inexpensive to buy okay quality units. These two are made in India. Whether that's better than China or worse, or Taiwan, who knows. The angle on this face here can vary on center drills. In this case, this is a 60-degree center. The 60-degree center is going to be better for the lathe in that it's designed to fit the same angle as the dead center. So this is 60 degrees here as well, so that it will match up closer in size there. This is happens to be an 82 degree. This is going to be a little bit better for drills because it's going to be a little bit flatter bottom, so it's going to engage. In an ideal world, this angle will match on your starter drill and your finish drill. So I've put a twist drill in here just for size comparison. This is an 1/8 inch twist drill. what you're really getting with the starter drill is rigidity. The body's much, much heavier. The thin portion that's going to start the hole is much, much shorter. So this gives you rigidity. On a thin bit like this, and even on larger bits, the length of it allows it to distort a little bit as it goes into the material, and your hole to then be going in at an angle or off center of where you want it to be. So that's kind of the idea behind a starter bit. So these last two bits that I'm going to show you, I like for cutting through metal if you're trying to drill larger holes, or if you're trying to enlarge an existing hole, particularly if you're using a hand drill rather than a drill press or lathe or a mill. These are commonly referred to as unibits. It's, I believe, actually a brand. Sometimes you'll hear these referred to as step bits. They're, depending on the quality that you buy, they can be fairly expensive. The brand name units of these run sometimes $30, $40 a piece, depending on the size. Whereas you can get you know, a set of 3 of these for $10 on an off-brand name. So to wrap up this video, I want to go over some common materials and recommendations that you might want to machine, or that you might not want to machine. To begin with, here in front, I've got several pieces of aluminum in different shapes, from square bar to flat bar and round bar. You can also get plate, hexagons, different shapes. Lots of extruded shapes with aluminum. This is 6061. Usually aluminum, particularly if you have a larger piece, it'll be stamped on the side. Here, obviously, the stamping has been cut off. The 6061 or 7075 is probably what you're going to want to mainly work with. 6061 from a cost perspective is lower cost and will work for the majority of what you're machining. The lower alloys, like those in the 2000 series and some of those that you might pick up at your home center, are just going to be too soft and gummy to machine very well. So stick with these. This is a good material to start with because it's fairly forgiving. It's not too hard on tools. You can cut it without lubrication, although lubrication or coolant is recommended. You can use either kerosene or WD-40 as a lubricant when cutting this stuff. These next materials over here that we're going to look at are all 3 brass. We've got a brass hex rod. This is nice for making punches or maybe some handle extensions, things along those lines. And then round and square bars. Brass, normally in a home shop or small shop situation, you're going to machine dry. It machines very, very well. It's a pleasure to work with. The biggest drawback about brass is its cost. It's a fairly costly material compared to aluminum. Here in the back, just to have it and to show it, is a block of wood. I wouldn't recommend personally using a metal lathe to lathe any wood pieces. The dust is not really great for the metal lathes, and the lubricants. The wood can mix in with those lubricants, and I just recommend avoiding it. You can do it, you just have to be careful. Sherline even makes accessories for turning wood specifically. And then over on this side, we have some steels. One of the tricks with steels is if you go to a scrapyard, you're going to have a real hard time finding out what it is you're buying. So these two are both pieces that I purchased at a scrapyard. I've cleaned this one up a little bit, as you can see. I have no idea what type of steel it is. There are so many alloys of steel that you can really run into problems with work hardening steel or high tensile steels that you're going to have a difficult time cutting. The other thing to be aware of is when you go to a scrapyard to purchase steel, it's probably going to be very rusty and covered in scale. This rust and scale can cause problems on your machines. This was also obviously cut with a torch and is very, very, very rough with lots of slag and who knows what else caught up in there. So one of the first things I did was cut it smooth with a bandsaw, just so I'd have a cleaner end to work from. But you'll just really have to make a decision whether you want to try to work with scrap metal or not. This is a piece of 4130 steel, if I remember right. It's going to be a little bit harder to work with, but it does produce a lot of results and doesn't distort very well. If you do need some steel parts, the first alloy I would recommend is a 12L14, I believe is the alloy. It's a leaded steel, it's free machining, so it's going to be a lot easier to work with for you to start and to learn on steel. Steel does almost always require lubrication. You can machine it free, particularly with the things like the 12L, and machine it dry, but you should have lubrication or coolant. This bar up front you've seen in some of the other setups that we've done as far as alignment. This is just a small section of O1 tool steel or drill rod or oil hardened drill rod. There are a lot of varieties of this. It's a precision ground material and is capable of, in this case, oil hardening. O1 is probably going to be one of your lowest cost as far as the materials of a drill rod, and it's going to give you good workability. You can start getting into like the A2 steels, the air hardened steels, or the W's or the D's, and there's many different varieties here, but you're going to spend a lot more for some of those. So this will work probably for most of your tasks in the machine shop. And then the last thing I wanted to point out here is a piece of cast iron. So cast iron you can certainly do, and there are other materials that I don't have shown here, like titanium and plastics and things along those lines. Cast iron, the one thing you have to be careful with cast iron is it's very abrasive. So it'll wear out your cutters really fast. It kind of creates a dust, and that dust will be abrasive to your lathe and to all the workings of your lathe. So make sure that if you are going to be doing cast iron, that you do a very good cleanup afterwards and get all the grit that's from it cleaned up. So again, that's just kind of a brief overview of materials. I would recommend starting with the aluminum. If cost is not a concern, or you want a nicer finish on a product, you can do 360 brass is the type of alloy in this brass, and it's the most common to machine. And then once you get some of this stuff down and are comfortable with it, you can move on to steels. Probably want to get a steel alloy you can identify, like 12L14, and by identify, that's usually purchase it directly as new stock. Identifying old steel is very difficult to do. I also don't have any stainless steel shown here, but obviously you can do stainless, and as I mentioned earlier, titanium and other more quote-unquote exotic materials on the Sherline lathe. They do have a lot of videos online if you do want to watch them, of them doing various test cuts in different materials at different feed speeds and at different depths of cut.